Welcome students. Now preparation of aldehydes and ketones are going on. So let's start the reactions, okay? From Grignard reagents. When Grignard reagent reacts with hydrogen cyanide or hydrocyanic acid followed by acid hydrolysis, we get aldehydes. When Grignard reagent reacts with any alkyl or aryl cyanides, when Grignard reagent reacts with any alkyl or aryl cyanide followed by acid hydrolysis gives ketone. Now understand the technique behind the reaction. Just write any Grignard reagent. It is methyl magnesium chloride. It may be bromide, it may be iodide. In most of the Grignard reagent reactions, acid hydrolysis is a must because we get one intermediate which gives product only by acid hydrolysis. You get aldehyde. Just write the formula of aldehyde. Use the alkyl or aryl group of Grignard reagent. So you get acetaldehyde. Just listen the technique. When Grignard reagent reacts with alkyl or aryl cyanide, the IUPAC name of cyanide is called nitrile. You get ketone. Follow the technique. So you see, this is alkyl cyanide or nitrile. This is aryl. This is a benzene ring actually. Write the keto group. To fulfill the tetravalency of carbon, just put methyl group in both sides. You get acetone. Do you know what is its name? This is benzene. If benzene contains COCH3 group, methyl ketone group, it's called acetophenone. So clear? If benzene contains methyl ketone group, it's called acetophenone. So in a nutshell, try to understand the reaction. Just technique. When any Grignard reagent reacts with hydrogen cyanide or hydrocyanic acid followed by acid hydrolysis, it gives aldehydes. And when any alkyl or aryl cyanide reacts with Grignard reagent followed by acid hydrolysis gives ketone. I think you understand it. Always whenever you do organic chemistry, follow the technique behind it. Okay, so let's start the next preparation of aldehydes and ketones, that is by hydration of alkynes. You know, alkynes, carbon compounds having carbon-carbon triple bond are called alkynes. There are two types of alkynes. One is symmetrical, in which the triple bonded carbon atom contains same number of hydrogens or groups. One is unsymmetrical, in which the triple bonded carbon atom contains different numbers of hydrogens. In case of symmetrical alkynes, when water is added, it undergoes addition reaction, and during addition reaction of symmetrical alkyne, no rule is followed. But in case of addition reaction of unsymmetrical alkynes, Markovnikov's rule is followed, and addition reaction of water with unsymmetrical alkyne is a very important for entrance. So please try to understand the next reaction, okay? Hydration of alkynes. The reaction is an example of addition reactions. When ethine reacts with water in presence of dilute sulfuric acid and mercuric sulfate HgSO4, we get acetaldehyde. When propyne reacts with water in presence of dilute sulfuric acid and mercuric sulfate, we get acetone. These are important for a board exam, but in entrance also it is important. In entrance, intermediate is asked. So try to understand the reaction and I will give the mechanism. Okay. Ethine, when reacts with water in presence of dilute sulfuric acid and mercuric sulfate, you get acetaldehyde. When propyne reacts with water in presence of dilute sulfuric acid and mercuric sulfate, you get acetone. The reactions are example of addition reaction with water. That's why it is called hydration. This is symmetrical alkyne. What are symmetrical? If the triple bonded carbon atom contains same number of hydrogen or group, that's called symmetrical. In case of symmetrical alkyne, addition reaction does not follow any rule. But this is unsymmetrical alkyne because the triple bonded carbon atom contains different number of hydrogens. So for unsymmetrical alkynes, addition reaction follows Markovnikov's rule. According to Markovnikov's rule, the negative part of the addendum which is attached, called addendum. The negative part of the addendum is attached to that triple bonded carbon atom which contains less number of hydrogen atom, and thus here Markovnikov's rule is followed. So let's start the first reaction, follow the technique. Second reaction, follow the technique. I will give the mechanism of the second reaction because this is very important for entrance exam. So here how to write it, okay? Just follow the technique. This is water. Just add water in this way, okay? It will be better. Now CH3 is the product. CHO. You get acetaldehyde. In case of propine now, follow the technique. In case of board exam, directly remember the technique. But in case of entrance, the intermediate is entrance question. This is propine. Just add water here. You can write water in this way also. So write CH3 carbon always possesses tetravalency, remember it, 1, 2, 3, 4. You get acetone as the main product. But in entrance, the intermediate is asked. So try to understand the mechanism of the reaction. This is unsymmetrical alkyne. This is called addendum, which is attached. Just break it. Hydrogen becomes positive charge, and here addition reaction for unsymmetrical alkyne follows Markovnikov's rule. According to Markovnikov's rule, the negative part is attached to that triple bonded carbon atom which contains less number of hydrogen. It is attached with one hydrogen, it has no hydrogen. So write it. To fulfill the tetravalency of carbon, triple bond will change into double bond. This is intermediate called enol, because this compound contains double bond, that is in and alcohol. That is all. That's why it is called enol. Enol is an intermediate, unstable. It's not a compound. It's an intermediate compound, not the final product. It readily undergoes tautomerism. This type of tautomerism is an example of keto-enol tautomerism. Because the enol form will change into keto form. See the tautomerism. This bond shifts here. As soon as this bond shifts here, the carbon becomes pentavalency. 1, 2, 3, 4, 5. But carbon never be pentavalency. You know that because it has no vacant d orbital. This pi bond shifts on this carbon atom and the oxygen releases the hydrogen atom. This hydrogen gets attached to the carbon. So you get this is enol form and this is keto form. Ketone group is there. Hence, this type of tautomerism is called keto-enol tautomerism. Keto-enol tautomerism. In another class, I will discuss about the tautomerism and resonance side by side. Okay, so please follow my classes. I think you understand it. Okay, so remember the technique of the reaction only, not try to mug up the reaction. Okay, so the next preparation that is very important, that is called Ettard reaction. Listen. You know that when toluene, benzene having CH3 on the head, undergoes oxidation in presence of oxidizing agents such as potassium permanganate and potassium dichromate, directly will change into benzoic acid, benzene having COOH, that is the CH3 will change into COOH, benzoic acid. In chemistry, potassium permanganate and potassium dichromate acts as strong oxidizing agent. So what you learn, when toluene is oxidized in presence of alkaline potassium permanganate or acidified potassium dichromate, as they are very strong oxidizing agent, toluene will change into benzoic acid. But in this case, the intermediate is Benzaldehyde, but we do not get it. Ettard reaction, ETARD, is the reaction which controls or retards the further oxidation of aldehyde to a carboxylic acid. That's why by Ettard reaction from toluene we get benzaldehyde, not benzoic acid. This is the significance. But remember it, during Ettard reaction, one intermediate is formed that is called Chromium Complex. That is the important for entrance. So, to understand the Ettard reaction, there is one technique to write the intermediate. So, please follow the technique and try accordingly. Okay. So, let's start Ettard reaction. This is Ettard reaction, okay. When toluene reacts with chromyl chloride, in presence of carbon disulfide as solvent, it's a non-polar solvent. Remember it, carbon tetrachloride, carbon disulfide, benzene, they are treated as non-polar solvent in organic chemistry. We get one intermediate called Chromium Complex, which on acid hydrolysis gives benzaldehyde. Very easy to remember, but the main thing is that this intermediate, follow it. Three hydrogen atoms are here. Write only one hydrogen atom. So we have not written two hydrogen atoms, okay. In this reaction, two molecules of chromyl chloride are used. What is the technique? Just shift one oxygen atom in front of chromium. Just shift one oxygen atom in front of chromium. Write as it is. 3 hydrogen atoms are here. We have written only one hydrogen atom. So take another hydrogen atom. Write the chlorine as it is. So this is called chromium complex. Okay, what is the technique? Just shift the oxygen in front of chromium. One hydrogen atom is attached with oxygen and hold 2, because you have taken 2 molecules of chromyl chloride. Actually, do you know chromyl chloride acts as weak oxidizing agent in organic chemistry? And remember it, potassium permanganate and potassium dichromate acts as strong oxidizing agent in organic chemistry. A question may come in your mind, if we use potassium permanganate or potassium dichromate instead of chromyl chloride, then what will happen? Remember it, if we use potassium permanganate or potassium dichromate instead of chromyl chloride, we get benzaldehyde. But as potassium dichromate and potassium permanganate are very strong oxidizing agent, the benzaldehyde, which is formed as intermediate, further undergoes oxidation under the reacting condition to give the final product benzoic acid. So we do not get benzaldehyde here. Okay, that's the significance of Etard reaction. Actually, Etard reaction is an example of controlled or retarded oxidation. So listen, another type of reaction is there by which also we can prepare benzaldehyde. That is by reaction with chromic oxide and acetic anhydride. When toluene is heated with a mixture of chromic oxide CrO3 and acetic anhydride, we get again one intermediate, actually brown colored complex, which on acid hydrolysis gives benzaldehyde. So let's try to understand the next reaction. Okay, again technique is there. So by using chromic oxide and acetic anhydride, when toluene is heated with a mixture of chromic oxide and acetic anhydride, we get one intermediate called benzylidene diacetate, which on acid hydrolysis gives benzaldehyde. Listen the technique. Follow the technique, how to write it. Draw benzene. 3 hydrogen atoms are there in toluene. Write only one hydrogen atom. Now here, do you know acetic acid, what is the formula? CH3COOH. CH3COOH. This is acetic acid. What is the technique behind it? Just write the acetate ion, that is CH3COO. Bas. This is acetate ion. Just write acetate ion, hold 2. 2 molecules here. This is called benzylidene diacetate. This is intermediate. You may ask me, sir, here 3 hydrogen atoms. Here you have written only one hydrogen atom. The rest 2, where they go? This is oxidizing agent, and the hydrogen atoms, the 2 hydrogen atoms combines with oxygen of chromic oxide to give water. No need to write. So I think you understand it. Now the next reaction is side chain chlorination followed by hydrolysis. Side chain chlorination followed by hydrolysis. You see toluene with carbon, 3 hydrogen atoms are there. If take toluene here, add chlorine atom, no reaction takes place. But whenever a mixture of toluene and chlorine is exposed to sunlight, reaction takes place. If you use insufficient sunlight, dim sunlight, diffused sunlight, then only one hydrogen atom is replaced by chlorine atom. But if you use a little bit excess chlorine and bright sunlight, two hydrogen atoms are replaced. If you use 3 molecules of chlorine, that is more excess, then 3 hydrogen atoms are replaced. So these are the substitution reaction, you know that. And any chemical reaction, if it occurs in presence of sunlight, called photochemical reaction. One very important thing for entrance, any photochemical reaction takes place by free radical mechanism. That's why the incoming chlorine free radical gets attached to the side chain, that is with hydrogen of toluene. So let's try to understand the reaction. Okay, this is toluene. When toluene reacts with chlorine in presence of sunlight, you know that the reaction is called photochemical reaction. And remember, any photochemical reaction takes place by free radical mechanism. That's why free radical mechanism always follows side chain reaction. That's why these hydrogen atoms are replaced by chlorine atom. So if you replace 2 hydrogen atoms by chlorine, then we get one intermediate. Okay, we get one intermediate. This is called benzyl chloride. This is called benzyl, B-E-N-Z-A-L, benzyl chloride. When it is treated with dilute sodium hydroxide or heated with water, the chlorine atoms are substituted by OH group of water. Here nucleophilic substitution reaction takes place. Nucleophilic substitution reaction. So the 2 chlorine atoms are replaced by OH group. OH. Carbon possesses tetravalency 1, 2, 3, 4. When this compound is heated, one molecule of water is removed and you get benzaldehyde, CH, double bonded O. Listen, one technique is there for entrance. Okay, follow the technique. This is very important for entrance. If any carbon contains 2 OH group, hydroxy group, on heating, one molecule of water is eliminated and we get aldehyde. If a carbon contains 3 hydroxy group, on heating, one molecule of water is eliminated, we get carboxylic acid. Okay, so remember this, very important. Let's do one entrance question relating with this idea. Okay. This is the question. I have seen a number of times this question in medical or engineering entrance exam. Toluene reacts with excess of chlorine atom. It's mentioned 3 molecules of chlorine atom. In presence of sunlight, we get one product. That product, when treated with dilute sodium hydroxide, we get another product, which on heating gives the final product. The final product is, options are given. The final product is, options are given. So let's understand the reaction. It's mentioned here that 3 molecules. So replace all the hydrogen atoms by chlorine atom. Benzo trichloride. This compound is called benzo trichloride. When this compound reacts with dilute sodium hydroxide, all the 3 chlorine atoms are replaced by OH group. You know that if any compound contains 3 OH group, on heating, one molecule of water is eliminated. That I have already discussed. You get carboxylic acid. That is, you get benzoic acid here. Okay, this is very important for entrance. I think you understand it. Now the next preparation of aldehydes or ketones, that's called Gattermann-Koch reaction. For board exam, direct Gattermann-Koch reaction is important for your time. But for entrance, one extra question is asked. Follow the both tricks and techniques. So by Gattermann-Koch reaction, we can prepare aromatic aldehydes, that is benzaldehyde. When benzene is treated with a mixture of carbon monoxide and hydrogen chloride in presence of anhydrous aluminium chloride and copper chloride as catalyst, we get benzaldehyde. The reaction is called Gattermann-Koch reaction. I think you understand, very easy to remember, but very important for your forthcoming exam. But in entrance, In entrance, the intermediate is asked here. Remember the attacking reagent. When carbon monoxide and hydrogen chloride reacts, they give formyl carbocation. Actually, CHO aldehyde has IUPAC name formyl, so it is called formyl carbocation. You know that any species having positive charge on carbon called carbocation. This is the attacking reagent or incoming electrophile. Whenever any atom or group is introduced on benzene, remember it, that is always an example of electrophilic substitution reaction. So for entrance student, remember two things mainly. One, this is an example of electrophilic substitution reaction, and the incoming electrophile, nowadays it is called attacking reagent, is formyl carbocation. Okay, I think you understand it. Now the next reaction, that is another important reaction. Okay, reaction by acid chlorides. So listen, when acetyl chloride CH3COCl, acetyl chloride or benzoyl chloride, benzene having COCl, reacts with Grignard reagent followed by acid hydrolysis, we get ketone. But do you know what is the problem of this reaction? The ketone which is formed undergoes further reaction with Grignard reagent and we get the final product, tertiary alcohol. But tertiary alcohol is not our target. Our target is to get ketone. So nowadays, to avoid the further reaction of ketone to alcohol, instead of Grignard reagent, dialkyl cadmium is used. You know that cadmium possesses divalency. What is the formula of cadmium dichloride? CdCl2. If you replace two chlorine atoms by two alkyl group, that's called dialkyl cadmium. So when dialkyl cadmium reacts with acid chloride, we get ketone. But the ketone does not undergo further reaction to alcohol. That's why nowadays, to prepare ketone, instead of Grignard reagent, dialkyl cadmium is used. So please follow the reaction. So from acyl chloride, this is acetyl chloride. When it reacts with Grignard reagent followed by acid hydrolysis, we get acetone. But do you know what is the problem of getting acetone here? That acetone further reacts with Grignard reagent under the reacting condition, and finally we get tertiary alcohol, that is tertiary butyl alcohol. But our target is not get alcohol. Our target is to get ketone, that is acetone. That's why nowadays, instead of using Grignard reagent, dialkyl cadmium is used. It may be methyl, it may be ethyl. Okay, dialkyl cadmium is used. Here it is dimethyl cadmium. When acetyl chloride reacts with dimethyl cadmium, we get acetone. But the usefulness of this reaction is that the acetone so formed does not undergo further reaction. That's why we get only acetone. Hence, this reaction with dialkyl cadmium is mostly used in industry. So it is a commercial method of preparation of ketone. Clear? So the next reaction, that is another important reaction, and this is the last reaction of preparation of aldehydes or ketones. So please be remain. This is called Friedel-Crafts acylation. You know that there are two types of Friedel-Crafts reaction. One is alkylation, one is acylation. Introduction of alkyl group, methyl ethyl group on benzene is called Friedel-Crafts alkylation. Introduction of acyl group, that is CH3CO, it is also called methyl ketone group, on benzene is called Friedel-Crafts acylation. And here we use Friedel-Crafts acylation reaction. Remember it, whether it is Friedel-Crafts alkylation or Friedel-Crafts acylation, in every cases the catalyst is anhydrous aluminum trichloride. One question is there in entrance. What is the use of aluminum trichloride during Friedel-Crafts reaction? Clear? So remember it, if you get this type of question in entrance, so the answer is aluminum trichloride, being Lewis acid in nature, acts as halogen carrier. Okay, so let's understand the technique of Friedel-Crafts acylation reaction. Okay, when benzene is treated with acetyl chloride in presence of anhydrous aluminum trichloride, then the acyl group or methyl ketone group is introduced on benzene. I have given star here because this carbon is attached with benzene. You know that in benzene every carbon contains hydrogen, so this hydrogen combines with chlorine to release HCl. And how to write the main product? Just attach this carbon atom COCH3. Can you tell me what is its name? Very important exam question. Direct question. This is called acetophenone. When benzene is heated with anhydrous aluminum trichloride and benzoyl chloride, if benzene, this is a benzene, if benzene contains COCl, that is called benzoyl chloride, then just attach this part with benzene. Actually this is benzene, this is benzene, this is keto group, this is called benzophenone. These two reactions are examples of Friedel-Crafts acylation reaction, okay? So, in my next class, I will deliver lecture on chemical properties of aldehydes and ketones. So, please remain with me and tell your relatives, friends, classmates to follow my classes. Thank you to support me.